I'm delighted to welcome you to this, our first Climate Academy session. It's great to see so many organisations represented on today's call. I think we had around 100 people sign up, and there's about 70 in the group just now, and hopefully more will join as we go through. That includes charities, small, medium enterprises, and also people in our supply chain and partner organisation. It's really great to see you. We appreciate your attendance and taking your time out of your busy schedules. I'll start with some housekeeping. We are asking everyone to keep their cameras off just to manage the bandwidth. Hopefully we'll have no technical gremlins on today's session, but if you're not presenting, if you could keep your camera off, that would be great. And also stay on mute if you can. This session will be filmed and will be shared. You've seen the notification pop up. We are hoping to share the session after each of the 6 modules. Clearly, not everyone will be able to attend every one, and we want to give the opportunity for people to go back and watch. I would encourage you to ask questions throughout. We do have and James will run through the agenda. We do have 10 minutes at the end for a panel session, but if there's any questions that pop up that you'd like answered, please do share them in the chat function, and someone from SSEN or the Supply Chain Sustainability School will be in answering those questions. And before I hand over to James, I just want to cover the reasons behind setting these up. Enabling net zero and driving sustainable outcomes is absolutely central to our business strategy as SSEN and that of the SSE group. From an SSEN perspective, that's best exemplified in our recently published business plan, where we've committed to reducing our carbon emissions by 55% by 2033, and have recently been accredited to science-based targets consistent with a 1.5 degree warming scenario. We're really proud of what we've done so far. We've got a long journey to go, but it's fair to say we've had a few hard yards to get there. We've run sessions internally within SSEN and really helped us as an organisation to understand the implications behind climate action and the science behind it, and that's why we really wanted to share this with our partners and supply chain. We think we've got a collective responsibility to help others enable their own journey to net zero. This session is the start of a 6-part series, with today being a general introduction and further sessions focused on areas such as setting of net zero targets, climate adaptation and circular economy. I would encourage you to sign up as much to many events as you can, but as I said, they will be shared afterwards. And someone will put the sign up link in the chat box as we go along. So welcome to the event. I'll now pass on to James at the Supply Chain Sustainability School to take you through today's session, and I hope you really enjoy it. Thank you.
That's great. Thank you very much, Graham, for that introduction, and welcome everybody. Good afternoon. It's a lovely sunny day for me here, so it's nice to see the blue sky and the sun for a change. We're going to take you through about half an hour on an introduction to climate change and carbon, taking you through where it comes from, why it's an issue, and importantly, what we can do about it. We're going to start from first principles. Essentially, we want to make sure that everyone on this call has got a really good understanding of what the issues are and where we can take them and what we can do with them. So some of this will be familiar territory to some of you. Treat it as a bit of a revision and picking up some new knowledge along the way. But we want to make sure everyone's got the same understanding of climate change and what we can do about it. So, as Graham was just saying, this is the first of 6 sessions. Just to give you a bit more detail on that, this one is the overview of climate change and carbon. And then we've got 5 further sessions coming up through February and into March, covering net zero on the 2nd of February, climate adaptation. So that's about coming to terms with what has already changed in the climate and how we can adapt to that on the 9th, followed by climate change and nature and biodiversity on the 16th. A piece on climate change and people, all the just transition stuff that I'm sure you're hearing coming out of SSE and other organisations as well. That's on the 23rd of February, how we can make sure that everyone is included in our move towards a lower carbon society. And then last but not least, climate change and resource efficiency, the circular economy, on the 2nd of March. The links to those, as Graham was saying, will be put in the chat box. You can sign up for those events through the Supply Chain website, as you did for today's. So please do go along when you get a moment to sign up to those that are of interest for you. They'll all be at the same time on the same channel. So today's agenda. In a minute, we're going to hear a video from Chris Birchall, who's the MD for SSEN Distribution. A few minutes from him setting the context. Then I'm going to take you through about half an hour, as I say, of what climate change is, how it's caused, and what we're going to do about it. And then there's the opportunity for Q&A at the end with a small panel of SSEN representatives. So by the end of it, you'll know what climate change is. I'm sure you've got a pretty good idea already if you've been watching the news over the last month. Importantly, though, how it's caused and how we can take action against it. So just to go over some of those house rules again, if you want to use the chat box for any questions, just drop your question into that chat box when it comes to mind. We'll pick those up at the end. Rachel Turner from SSEN will be moderating and facilitating that and looking through the questions. Do share your feedback at the end, please. We'll send around a link with the follow-up communication to get your feedback on what you liked and what more you might want to hear from SSEN. And finally, the slides and the recording will be shared with you. So if you want to take notes, please do, but you will get a PDF copy of the slides that I'm going to take you through right now. So first of all, as I say, we're going to hear from Chris Birch, Managing Director from SSEN, and I'm just going to check actually that I've got my, I just stop for a second, and I'm going to reshare that, if you don't mind, just to check I've got the sound being shared, because I don't want you to race ahead with that. Okay.
Thanks, James, and welcome everyone to what is the first of 6 sessions of our Supply Chain Climate Academy. My name is Chris Birchall and I'm the Managing Director for SSEN Distribution. I've now been in the business for just over a year, and during that time I have come to understand just how critical the role is that distribution companies must play in the overall delivery of net zero. Now, freshly out of COP26 last year, it has never been more urgent to act now. And we're doing that through learning and working across boundaries. More so than ever before, we've all got a role to play and we can move forward together. The climate crisis is driving unprecedented levels of change, which requires an unprecedented pace and scale of response. Meaningful actions across the energy system are urgently needed to mitigate the impacts of climate change and make net zero a reality for our communities. We also have to take responsibility for our own impact. Recognizing this, we took action, and in October of last year, we became the first DNO to set an accredited science-based target that limits global warming to 1.5 degrees above pre-industrial levels. Now that means a commitment to reduce our business carbon footprint by 55% by 2033 for Scope 1 and 2 emissions. Now, part of that goal includes a target that 35% of our supply chain will have set their own science-based targets by 2026. Our core purpose is to power communities to thrive today and create a net zero tomorrow. It has to be central to everything that we do. And as we enter the last year of ED1 and look to increase and ramp up our activity in ED2, where we're proposing to invest nearly £4 billion over a 5-year period, we recognise that our supply chain and delivery partners play a fundamental role in our daily and longer-term network operations. For that reason, we're holding these sessions to help build knowledge, awareness, and drive understanding of the critical climate issues that we will face and how to better manage them. Today, we kick off with a session designed to give an overview of climate change and carbon. And over the next 6 weeks, we will dive deeper into the issues that we face as a planet, covering climate change and nature, net zero and setting targets, climate change and people, climate and waste. And because climate change is already happening, we will cover climate adaptation too. We'll hope you'll fully engage with these sessions as you plan your own climate journey and that you'll find them helpful. And just before I hand you back to James, I would like to thank you all for attending and thank the Supply Chain Sustainability School for helping us to put this together. Collaboratively, we can all achieve the ultimate goal of a cleaner, greener future for us all. Thank you, and back to you, James.
Great. Well, that was really good to hear from Chris. Hopefully that all came through okay with you on the technology. We're now going to ask you a few questions, you as the audience, and we're going to get some Zoom polling questions up on the screen. You can simply click the answers that you see are appropriate. So first of all, we've got the first question here is how much do you know about climate change on a scale of 0 to 10, where clearly, or 1 to 10, where 1 is very little and 10 is lots. If you click the radio button that you think is best for you, don't sweat it, don't worry about it too much. This is all anonymous. We just want to get a sense of where we think people are at in terms of their knowledge. So we'll give it a few seconds for you to input your responses, and we'll share the results as well. Great, I think we could probably move on to the next question. Second question, does your organisation have a carbon reduction strategy? Yes, no, in development, or don't know. Again, just choose one of those 4. And as you scroll down the box, you might not have realised this, but if you scroll down in the polling box, you can see on the screen, you can see the 4 questions that we have for you. So the third question is, if you do have a strategy, do you measure and report your carbon emissions as part of that? Again, yes, no, in development, don't know. And then the final question is, who has the most influence in this space, in your view? And it's a multiple choice. You can have government, clients, contractors, products and suppliers, academia, investors, or the general public. So if you answer all those 4 questions and then hit submit when you're done. And then Bryony, when you're seeing a good level of responses coming in, close the poll, please.
Yeah, no problem. We've got 67 of 81 so far. I'll give it just a couple more seconds and then I'll share.
Thank you. Great, so here are the results. Hopefully you can see those yourselves on the screen. So in terms of how much do people know, there's a nice distribution, almost a Gaussian distribution there, with majority coming around 5, 6 or 7. So many of you will know a lot of the stuff that we're going to be talking about, but as I said earlier, making sure that people are not left behind, so everyone else gets some knowledge there. Whoever answered 9 out of 10, we might be coming to you in the panel Q&A if you have any tough questions. Okay, the next question, does your organisation have a carbon reduction strategy? A good 60% of you have said yes, which is wonderful to read, and are following a further 27% saying in development. So we're looking at 88% with a carbon reduction strategy of some sort, which is wonderful to see, and others to follow on shortly, I would assume. On the third question, if you do have a strategy, do you measure and report your carbon emissions? Again, similar numbers there. We're looking at over 80% saying yes or in development, which would match the strategy. Should you need support on how to go about setting strategies or developing metrics and KPIs for capturing carbon data, then start with the Supply Chain School. It's a free resource. You can get lots of good information from that. And then the final question, who has the most influence in this space? Government coming out on top, probably unsurprisingly, but clients and contractors as well, having a very high influence. I think the most interesting one I'd like to pick up on there is the general public. I've got a strong influence on changing behaviours, kind of community drive to change the way we live and work. Wonderful, thank you very much. That's really useful, great. Okay, so on to the main part of the session. Understanding climate science and where carbon emissions come from. So taking this right back to first principles to make sure that we all understand what this is all about. this all leads back to the greenhouse gas effect. It's a perfectly natural phenomenon that the Earth and the atmosphere traps the sun's energy, and it warms up the planet. Without it, the planet would be far too cold for life to exist as we know it. Our atmosphere keeps the global average temperature to about 15 degrees Celsius, which means we have liquid water and we have life as we know it. So greenhouse gas effect is a normal effect that we do need. But what we're doing is inadvertently exacerbating it. We're making it more extreme. In effect, we're putting an extra duvet on the atmosphere. We're putting another jumper on, in effect. And what that means is that we're trapping more of the sun's energy and heat, and consequently the Earth's temperature is going up in temperature, because in effect the atmosphere is thicker with those gases in there that are stopping as much of the sun's heat radiating out into space. So some other information, some other evidence to suggest that and to demonstrate that we are actually causing increased climate change impacts. What we do, the graph we're looking at is the concentration of CO2 in the Earth's atmosphere going back over 800,000 years. And the blue line shows the fluctuation in that concentration up and down over time. So the horizontal axis is clearly time going back 800,000 years, and up the vertical axis we've got the concentration in parts per million of CO2. And as I say, you can see it fluctuates between somewhere around 180 parts per million to about 300. When it's higher, we have warmer periods in the geological record, and when it's lower, we have ice ages. But you can see that on the right-hand end, it ticks up, it goes up very extremely, sometimes called a hockey stick graph. And just to put some idea of how that relates to our history, that's roughly when we appeared as a species. And then the other red line there is when agricultural civilization took hold. So you can see the fluctuation was fairly steady going back through time, but we've affected it quite a lot in more recent times. And a lot of this data is being gathered from ice cores taken from the Antarctic and other places where they can measure how much CO2 is in the atmosphere going back into geological time. Bringing that more recently, and it's a slightly different graph this time. So whilst it's still time on the x-axis, it's temperature on the y-axis. And what this is showing is the deviation, the change in temperature of the Earth on average at the surface, compared back to levels around 1850, so before the Industrial Revolution. And this graph is showing that the temperature on average has gone up by over 1 degree Celsius. That might not sound much, particularly on a cold winter's day, but globally it means that a lot more energy and heat is trapped within the Earth's atmosphere, within the system. And that's what's leading to climate change impacts. So relatively small change in temperature can lead to devastating weather and climate impacts. Putting some more information on that, again, more evidence to demonstrate where climate change is coming from. This graph is showing the amount of carbon dioxide that has been emitted over time by various different countries. And you can see that from 1750 through till about 1850, it was a flat line. This was before the Industrial Revolution. But it's gone up steeply. Again, it's that hockey stick graph. It mirrors exactly the concentration of CO2 in the atmosphere. It mirrors the temperature going up. So the rise in CO2 emissions have been since the Industrial Revolution, and really since 1950 as well. It's really steeply gone up since then, after the Second World War. And what we're seeing in this graph, and again, the y-axis in this case is the amount of CO2 emitted per year going forward. And you can see that, it's very steep in more recent times, and some of those key countries and regions that are doing or causing most of those emissions. So what I'm trying to build up here is a layer of evidence to say we've got ice cores from Antarctica with CO2 concentration, measured temperature changes, and the actual emissions, the recorded measured emissions from various different countries. All these things overlay and stack up. And what's the outcome from that? You'll have seen weather reports, you'll have seen news reports over the last few years. You'll have probably watched documentaries with David Attenborough and Greta Thunberg, and there's lots of recorded news and increasingly so about the adverse impacts from climate change, whether that's extreme floods, whether it's extreme wildfires or ice melting in the Arctic, for example. These are all different impacts of climate change. climate change is effectively a multiplier. Many of these weather instances are natural phenomena. They happen anyway. We get hurricanes in the Caribbean in the hurricane season. But what climate change is doing is exacerbating them and making them more frequent and more extreme. The damage they cause is a lot higher, both to life, to property, to nature, but they're happening more often as well. So we have to be careful here about differentiating between weather, which is what we see out of the window every day, as opposed to climate change, which is a longer term trend. What we're seeing is that the frequency of those forest fires is more often, and they're happening in places that wouldn't have otherwise normally had them. So the one in Australia a year or so ago is quite a natural effect, but it happened more severely. And the likelihood of another one coming in such severity quite soon is a lot higher than it used to be. So who are the biggest culprits in this? A few global pictures here of where CO2 emissions come from that match the graph I showed you a couple of slides ago. Obviously, the deeper the red, the more carbon is emitted by those countries. And unsurprisingly, China and the US top those charts. They're big countries with lots of people and lots of industry. So they contribute loads. China at well over a quarter of global carbon emissions. And you can see the UK and Ireland on there as well as a relative marker. That's not to say that we shouldn't do anything. We all have our part to play. Each country has its part to play. But you can cut this data in slightly different ways. When you look at it as a per capita, so per person of emitted carbon, you see that the story changes slightly. The US is still quite high up, but China has slipped back down there because, yes, they emit loads as a country, but on a per person basis, it's a lot lower. So we have to look at this in the round, and this is part of the just transition and the inclusion piece. India, for example, as a nation state, emits a lot of carbon, but per person, it's very, very low. So we have to make sure that we don't race ahead with new technologies and leave parts of the world behind because they simply can't afford it yet. They're not ready for it yet. But looking at this is more about lifestyles and access to lower carbon forms of fuel and transport and so on. I put Qatar in there just as an example of how high that number can go. And then another important part of the story, linking back to the Industrial Revolution, is the cumulative emissions per country. So this is going back in time, how many tons of carbon have been emitted by each country back to the Industrial Revolution. And you can see here that the UK jumps up the rankings for obvious reasons. We were the cradle of the Industrial Revolution, and then all those bigger emitters are there as well, like the US and Russia. So there's a complicated story here. There's no one single country or one single area that we should point to in terms of how we deal with our carbon emissions. We need to deal with what's happening now, but we also need to take into account what has happened in the past, because that's part of the legacy as well. So in terms of which sectors the carbon emissions come from, this is one of many graphs that you can find out there, but it's quite simplistic and it's all quite easy to access and understand. And you can see those big macro sectors where emissions come from. And breaking it down a little bit more into some of the detail here, you've got 3/4 there, which is energy consumption, so direct consumption of fossil fuels that lead to the emission of greenhouse gases. But then you've got about 1/4 of that pie chart, which is other emissions that are not directly linked to fuel. So that's agricultural emissions from livestock, from farming practices, the decomposition of waste materials that will give off greenhouse gases as well. And similarly, you can get some industrial emissions that create greenhouse gases inherently as well as consuming fuel as part of that process. So that's why industry there is at 29%, because it's not just the direct energy consumed in industry, it's also that grey wedge that you can see with 5.2%. That's other GHG emissions that are emitted as a consequence of manufacturing something in industry. And similarly, you can see agriculture and forestry is pretty important there as well, as is transport and building. So again, what I'm trying to get across here is that each sector has its role to play. Each sector has a different way of dealing with its GHG emissions. We all have to contribute to the greater goal. There is no one silver bullet to say, if we do this, then we've solved it. Some of you will remember the Montreal Protocol for CFCs and the ozone hole layer. That was a big issue and something that the global community needed to solve, but it was a relatively straightforward solution. Let's not use CFCs anymore. Let's use different propellants and different refrigerant gases. Still took a lot of time and a lot of discussion, but it was a simpler process to go. So part 2, carbon literacy. Some fundamentals here. So a little bit of teaching about the different aspects of carbon accounting and greenhouse gas emission reporting. There are 6 main greenhouse gases. Most gases have an impact on the atmosphere, but there's 6 main ones that we want to focus on. And that's a consequence of the Kyoto Protocol that happened a few years ago and has been followed through with the Paris Climate Change Agreement and more recently COP26 in Glasgow. So you can see those 6 gases on the screen. I'm going to take you through them. Carbon dioxide is the most prevalent. Obviously, it's a combustion byproduct. If you burn anything, it'll give off CO2. And that's notionally given a value of 1. There are no units here. This is a relative scale. Methane, CH4, is the next one, and that has an impact over a 100-year timescale of 28 relative to CO2. And as the diagram shows, if you release a kilo of methane, it's like releasing 28 kilos of CO2. So you want to be careful about how much of these gases you release. Working down the list, we have nitrous oxide, which is almost 300 times as potent as CO2, kilo for kilo. And N2O comes from various agricultural processes, whether it's the use of fertilizer or the decomposition of waste materials. It has other industrial uses as well as a propellant gas in food products and other sources as well. So a very, very potent gas, and it has a long residency time in the atmosphere. It survives a long time before it gets consumed. SF6, many of you will be aware of, using high voltage switchgear as an insulating gas to prevent fire. Huge impact, over 23,000 there compared to carbon. So again, a kilo of that is like emitting 23 tons of CO2. And then we work into the hydrofluorocarbons and perfluorocarbons, which have their families of compounds, as I'm sure many of you know. So it's not just one specific chemical. They have a range of global warming potentials relative to CO2. And those compounds are used in fire suppressant purposes, but also in refrigeration gases and so on. These are all expressed in tons of carbon dioxide equivalent. So if you ever see a level of emission that's reported with the little e at the end of CO2, that's talking about their equivalency, so tons of CO2 equivalent. So you convert all those emissions of methane, SF6, or any of the other gases into CO2 equivalent. It's like converting your dollars to pounds, euros to pounds. It's just an exchange rate mechanism, so we can compare and contrast more easily. So some other ways of comparing and contrasting different products, different processes, and there's many of these databases out there. I'll touch upon them a little bit later, but this is just some examples here, how you can compare different transport impacts for the same distance, in this case 500 kilometers, whether it's traveled by train, by car or by plane. And we all know that traveling by plane is more impactful for the environment, but this puts numbers on it, on how much more impactful it is on a per passenger basis. That's what the P stands for, per passenger. So having this kind of information is really useful to help us make decisions in our design, in our delivery of our product, in our procurement and our supply chain interactions as well. Without this knowledge, we're kind of fumbling around in the dark a little bit as to which solution or which option might be the better one for carbon. Something closer to all of us is food. This was produced on the BBC, and I grabbed this one because it's a great graphic. It shows it very, very simply. It shows the carbon impact of various different foods on a per portion basis. And as we all know, again, any of us who've watched Green Planet, Blue Planet, any of those documentaries or other programs, that meat has got a higher, or red meat particularly, has got a higher impact per portion, per kilo, than white meat and then a vegetarian or vegan diet. And this puts some numbers to that as well. Clearly beef and lamb are at the top. They're both ruminant animals. Their digestive system creates methane inherently, so that's why they have a higher impact, plus all the feed that needs to go to them, when they're overwintering. You can see those relative different impacts down there. What's important about this is that there isn't just one fixed number. As you can see with the ones near the top, there's a kind of a low, a medium and a high, and it depends how those products are produced, how those animals are grown in this case, looked after, where they are looked after. And it's the same with all the products and materials we use in what we deliver. Where does it come from? What's the shipping? Is there recycled content in that? What was the energy they used to manufacture that product? All these things go into how these numbers are created. So to put some kind of science behind it all, how is a carbon footprint actually calculated? It's very, very simple. At its core, it's a very simple calculation. You need something called activity data, and that could be litres of diesel consumed, which we'll see in a minute, or kilowatt hours of electricity consumed, or tons of products used. then you need an emission factor, some kind of data point that converts the litres or the kilowatt hours into your kilos of carbon dioxide equivalent. That's your carbon emission. So it's a very simple multiplication at the core. So here's the example, as I suggested, with diesel. 250 litres of diesel is your activity data, and you'll get that from an invoice or a bill or off a pump. And the emission factor in this case is 2.75 kilos of CO2 equivalent are emitted per litre of diesel. So someone somewhere has done a laboratory experiment, they've burnt diesel as a fuel, and they've captured and calculated how much CO2 is given off. That's great for us because we don't need to do that. We can just look it up on a table, and there are lots of these tables are out there for free to access. And that gives you your carbon emission, almost 700 kilos of CO2 emitted for that amount of diesel being burnt. That is your carbon footprint, quite simply. Now, in reality, of course, it's going to be a lot more complicated than that. You need to do it many times over for different functions and different operations, but that fundamentally is it. As I mentioned earlier, the E in CO2E takes into account other gases that are emitted at the same time, quite often methane and nitrous oxide, but others as well. So something that you might have come across and might not be sure what it means is the different terminologies, scope 1, 2, and 3. So I'm just going to take you through those briefly to give you an overview of what those mean. And they're increasingly important. They're not jargon anymore. People use them as day-to-day terminology to describe which emissions they're talking about and to help explain what they're dealing with. So fundamentally, there's two kinds of emissions. There are direct emissions, those where, in effect, you put the match to the fuel yourself. You are using that diesel, you control and own that vehicle or that piece of equipment or the gas that goes through the boiler system that you have. You own it, you control it, you are burning it. So it's your direct emission. You are causing that inherently. That is known as your scope 1 emission. It also applies to fugitive emissions. If you've got air conditioning units, for example, and they have a small leak, a fugitive emission, that's also a greenhouse gas. You have caused that, you are in control of it. It's your scope 1. Everything else is an indirect emission, goes without saying. So this is where you are paying for a service that or a product that requires energy input in some shape or form. Those lead to greenhouse gas emissions. So you are indirectly responsible for those greenhouse gas emissions because you have paid for that service. You've given cause for those emissions to be created. And there's two kinds of indirect emissions. There's scope 2, which is generally speaking your electricity. But if you have district heating, for example, as well, it might be heating and cooling that comes from that energy consumption as well. But generally speaking, in most cases, it's your electricity consumption from the grid. You've gone to an organization, SSE, for example, and you've purchased power from them. They have at some point burnt some gas as well as other sources of power, of course, that has given rise to the greenhouse gas emissions. So that's indirect for you. You account that for scope 2. Everything else is your scope 3 emissions. Generally speaking, that's shortened to supply chain. If people talk about the supply chain emissions, they're talking about their scope 3 emissions. So that could be the products and services you bought. It could be your business travel and commuting. If you have any leased assets that go with that, any waste from your operations, again, you're paying someone else for that service, for that product outside of electricity, and that is counted as your scope 3. So how do we reduce our emissions? I'm sure many of you have heard of the waste hierarchy. Reduce, reuse, recycle, and work towards a more circular economy. Unsurprisingly, there's a similar kind of hierarchy with carbon and energy. It follows the same kind of philosophy, same kind of mantra. And at the top, it's basically saying avoid using energy if you can. If you can do something that doesn't require energy input, then great. So it might be some kind of passive design in a building construct. So you need less artificial light or less artificial heating and ventilation. If you can do that, then great. But in reality, we will need to use energy at some point in some shape or form. So where we do need to use that energy, we should look to reduce it as much as possible, be more efficient with what we're doing, whether that's the equipment or how we're running the equipment itself. And that brings in behaviors, how people operate equipment, but also in terms of how much material we consume and what kinds of materials we consume, because inherently that will have what's known as embodied carbon in it. It's the energy that's being consumed and the greenhouse gas emissions that have been given off as a consequence of creating that material. So we're bringing in concepts here of leaner design as well, maybe even off-site manufacturing, for example. Then if you have the ability, switch to lower carbon forms of power, where you can use renewable sources of energy or materials that have been created with renewable sources of energy as well, rather than kind of the grid, the standard grid average or the standard materials and fuels that we always consume. And only when you've been through all of these processes should you think about compensating and offsetting. So this is a flow chart as well as how we should put our carbon reduction plans in place. Make sure we've done everything we can to avoid energy use, to reduce our consumption of energy where possible. And then when we've done that, think about, okay, we've got some energy left over that we just can't get rid of yet. We still need to use that energy. And sadly, those greenhouse gas emissions are given off. What can we do to compensate for that? How can we offset or remove those greenhouse gas emissions from the atmosphere? But don't jump straight to that. Okay, section 3, taking action from global cooperation to individual behaviour. Firstly, global cooperation. The whole conversation around climate change is not new. It's been going on for a long time. And if we look back in time to 1987, when the Brundtland report came out, and that was all about sustainable development. It's about ensuring that the needs of today don't compromise the needs of the future. I paraphrase there, but I'm sure you've heard that quote on what sustainable development is. So making sure that the world can be sustainable, it can regenerate. So that was more than just climate change, but that's clearly part of it, that we have a stable ecosystem within which to live and work. Very soon after that, we have the Earth Summit in 1992 in Rio de Janeiro, and that looked at driving this agenda forward, and they created Agenda 21, which was about how we are going to live and work through the 21st century where we are now, and improve how we treat the planet, how we treat people, and climate change was a key part of that, and that led to the creation of the United Nations Framework Convention on Climate Change, the UNFCCC, as a body focused purely on climate change and the impacts it has on the planet, on biodiversity, and on people. And it's the UNFCCC that runs all the COPs, the Conference of Parties, the one in Glasgow last year, for example. Winding forward a bit, we had the Kyoto Protocol. I've already touched upon that a little bit in 1997, and that was the first landmark piece of agreement to say we're going to focus on these gases, the 6 I showed you earlier, and put plans in place, 15-year plans on what we're going to do as a globe, as a world, to work towards lower carbon emissions. Again, bringing it further forward to now, or closer to now, the Paris Climate Change Agreement, which occurred in 2015 and was ratified in 2016, was again a landmark piece of agreement to get pretty much every nation state on the planet to agree to reduce emissions. And something that came from that was nationally determined contributions. So each country saying, this is going to be what we're going to do about it. Not legally binding, but an agreement to say these are the efforts that we're going to take as our country to reduce our emissions. And the UK set some very bold targets on that back then. And obviously, 2 or 3 months ago, we had the latest version, COP26 in Glasgow, with some really good discussions and some agreements about how we're going to continue to reduce CO2 emissions. So there's going to be an update. Each member state has been asked to update their nationally determined contributions, and agreements to reduce methane as well, because that's the next one waiting in the wings. We've been very much focused on direct energy consumption and CO2, but we also need to look at methane emissions as well. So one of the agreements from that was to reduce methane emissions by 30% by the year 2030. And that's a key one that we can follow up at another time. So yeah, just on that, the UK's NDC is 68% reduction versus a 1990 baseline by the year 2030. So those are our territorial emissions, how much we emit as a country, and bring them down by about 2/3 compared to that 1990 baseline. So it's a big ask, and it's one that we're well on the way with, which will come to in a second. But each country has its own NDC, as they know. So in the UK, we have the Climate Change Act that was brought into force in 2008, updated in 2019. And this is where the phrase net zero comes from as a country. So territorially, we're trying to get down to net zero emissions by the year 2050, again, based on that 1990 baseline. And we use 1990 because it's a year where we've got a good set of data. If we go any further back than that and the data isn't quite as good as we want it, so we use 1990 as the baseline and work from that moving forward. So the graph you're seeing now is showing you, again, you've got the timeline along the horizontal, and on the vertical, you've got the emissions of carbon greenhouse gases from the UK territorially. And you can see that's in megatons of carbon dioxide equivalents. That's million tons of CO2 and methane and other gases that are in that basket of 6 that I talked about earlier from Kyoto. And you can see the black line shows our territorial emissions have come down about 40% since 1990. A lot of that has been due to grid decarbonisation, but other reasons as well. So that's good progress, but it gets harder. We need to keep carrying on down that trajectory down to net zero with that dashed purple line. I'll just bring up some of these here. So we've all got, across the UK, we've got this net zero target to achieve that. And Scotland and Wales have got a slightly different version of that through devolution, and rightly so. Slight variations because of the economy of the devolved nations. The Republic as well has got its own similar target for anyone who's dialing in from Republic of Ireland. But we can see in that graph, you've got these kind of blocks underneath it that say CB4, CB5, CB6. These are carbon budgets, 5-year carbon budgets on what we're going to do, the actions we're going to take as a country at a macro level. So what's the housing sector going to do? What's the power sector, the transport sector, the agricultural sector? What are these sectors going to do? What are the activities they need to put in place and the different technologies they need to achieve continuing carbon reduction going forward? And importantly, earlier in 2021, I think it was March in 2021, maybe April, the government came out with an intermediate target, legislative target, that we reduce our emissions by 78% by the year 2035. So we're going to be net zero by 2050, but there's an intermediate target in 13 years' time to be 78% reduced compared to where we were in 1990. So that's still on that same purple line trajectory, albeit now we have a legislative milestone in there to hit. Make sure we're doing what we said we're going to do effectively. Okay, and on an individual level, there's many things that we can do. We all have a part to play, personally, at home, in our jobs, in our organisations that we work for. And here are just a few examples, and I'm sure you'll have seen many of them before. It's not an exhaustive list. You can see there's things that we can do at home in terms of how we heat our home, the kinds of food that we eat. I'm by no means saying that we should all go vegetarian or vegan, but it's about having a balanced diet and considering what we consume and how we consume it. And then importantly, travel as well. It's been evident over the last couple of years that our work and travel patterns have changed, and I think probably changed forever. You know, we will still go into the office and go to site, but maybe a bit less frequently than we might have done 2 years ago. And then lastly, what we consume. The products and services that we buy. Some of that is being done for us as we move away from vinyl and CD onto streaming services and so on, but there's other things that we can look at as well. So just a few examples there. And as I say, when you get the slides as a PDF, you can have a look at that as well at your own leisure. And lastly, I just want to cover something that SSE has done more widely with an organisation called Do Nation. Do Nation are an NGO, a not-for-profit, and they work with businesses and organisations to help them put actions in place, micro actions on a personal level that cumulatively all add up to a big change. And it's getting people involved across business. It's not just led by a sustainability team or a team. It's including all kinds of people. So SSE have worked with Do Nation on this to energise people and encourage people to take some actions on what they can do. So I'm just going to give you a few examples here that pop up on the screen. And it's little things, you know, it's turning the thermostat down by 1 degree. It's about drying your washing on the line, it's the right kind of weather, rather than in the tumble dryer. It's about taking a different form of transport to work, you know, rather than driving, maybe getting the train. It's thinking about what you eat. So all these micro actions all add up, and you can see some of them on the screen here. And what Do Nation do is they provide the service that says you can sign up, you can pledge to do these activities, and then they create a kind of Blue Peter style accumulator kind of chart in terms of what is being pledged to and what is being saved. So again, it's about engagement and commitment. And that's me done for the moment. Hopefully you found that interesting. Hopefully there were a few nuggets in there if you're well up on climate change already. I'm now going to hand over to Rachel Turner, who's going to lead on the Q&A that we have with all the questions that you've been posting during my session.
Lovely, thanks, James. That was an excellent summary. So thank you ever so much of the climate science, the carbon accounting and actions.